Smart Sensors Incorporated has been a nationally recognized and active manufacturer and seller of quality industrial RTD and thermocouple elements and temperature assemblies for nearly 25 years. Now, SSi is a proud part of the expanding SOR family of companies. You can now access these products under the SOR name brand and provide your customers with a broader range of quality temperature solutions when the need arises. RTD stands for Resistance Temperature Detector. The most common construction is the newer thin film design, instead of the original platinum wire wound around a ceramic mandrel. Thin film relies on platinum etched onto a ceramic substrate, sort of like an IC chip. The result is a very accurate and low-cost element. The most common construction for RTDs is the 3-wire RTD. The RTD element has two terminals, positive and negative. The third wire is added to compensate for the errors that a simple 2-wire construction generates due to the uncompensated resistance from the extension wire. For even better results, a 4-wire construction cancels out any imbalance due to variations in lead wire length. RTD accuracies are defined by several industry standards, ASTM and DIN. The most common accuracy supplied is the grade B, which provides a plus or minus 0.8 degrees C limit of error at 100 C. Grade A cuts that error in half, and SOR offers a high accuracy A+, or 1700 series element that is 10 times better than a grade B. RTDs start with an RTD element, thin film is standard, which is soldered to Teflon or fiberglass lead wires. Standard OD for RTDs is 1/4 inch with 3/8 inch OD tubing available, and in 316 stainless steel or alloy 600 for higher temperatures. The standard element used is a 100 ohm platinum. At 0 degrees C, the element reads 100 ohms. Sometimes a 1000 ohm platinum RTD can be specified. A typical RTD looks like this. Starting from the bottom, you have the tube with a welded cap on the end. Lead wires are soldered to the RTD element that is inserted to the bottom of the tube. A moisture-resistant potting compound fills the open end and helps seal the back connection from moisture. A spring is also added for use in a thermowell and can be removed as needed. Other options include the addition of a thermowell, or a protective tube, that is inserted into the process so that the RTD can be easily replaced without shutting down the line or process to remove the sensor. Various extension options are available to get the connection head up and away from heat sources, so the terminations can be made in an ambient temperature zone that is safe and convenient. Finally, an optional head-mounted temperature transmitter can be utilized to provide a 4 to 20 milliamp signal rather than running long distances with extension wires to a controller. These are just some of the packaging options available with a typical spring-loaded RTD. Oil and gas applications include a variety of thermocouple and RTD opportunities. Focusing on the RTD opportunities, rugged elements designed for high vibration applications can be provided that use a special MI cable core rather than a hollow tube that is loose-filled with magnesium oxide powder. Numerous flanged and threaded well assemblies are usually required for pipeline measurements and process tanks at compressor stations and gas production plants. RTDs for measuring the upstream and downstream fluid temperature are extensively used for metering skid packages as critical temperature inputs for flow computers. And bearing temperature RTDs are another commonly found application. Refineries have a wide range of temperature sensor requirements, and process temperatures below 1000 degrees F are often done with RTDs. Flanged or threaded thermowells are used in reactors, tanks, and pipelines throughout the various units found in a refinery. We also provide a variety of special multi-point assemblies, whereby a single tube can contain as many as 40+ measurement points along the length of the assembly.